All right, so solving some equations. Again, the idea is get the variable on one side by itself by doing the same operations to both sides. So here we have the variable b. Oops, gotta do this. Here we have the variable b. So the first thing I want to do is I want to get rid of the 7, the minus 7. The opposite of minus 7 or subtract 7 is add 7. So I'm just going to do this. I don't want you to have to rewrite the whole line and put, minus 7 plus 7. I know your teachers may have said that in the past. Just put a plus 7 on both sides. Okay? Now we've got 3b equals 27. Another way of doing that, which I'm fine with, is if you had done this and put plus 7. That's showing what's happening going from this step to that step. Okay? Anyway, now we have 3b equals 27. Let's divide both sides by 3 because this right here is multiplication and the opposite of multiplying is dividing. So now we have b equals 9. If you take this 9 and put it back there, 3 times 9 is 27, minus 7 is 20, which equals to the right side, which works. So we know we did it right. Okay? Okay, next one. Oops. Move down a bit. All right. Now this one is different because it's got variables on both sides. So I want variables on one side. So I'm going to get rid of the variable on one side. Well, you know what? I'm going to get rid of it on this side because 6w is bigger than 2w. I could have subtracted 6w from both sides, but I'd have a negative then. I'd have negative 4w on the left-hand side. I don't like negatives. So these cancel off. That's why I did it. Now I've got 11 equals 4w minus 17. Next thing, I'm going to add 17 to both sides. My next line would be 28 equals 4w. And I'm going to do this. I'm going to go plus 17. In the last step, I don't like the 4. I'll divide both sides by 4. Those cancel off. That's why I did it. And I will have w equals 7. Notice I put the w on the left-hand side for the final answer. I don't care which side it's on during the solution, but at the end, w equals 7. All right. One extra little step. Before we start, simplify if you can. So we're going to start off with 4x minus 5 equals x plus 17. This time, we have x and 4x. 4x is bigger, so I'm going to leave the x's on the left-hand side, which means I'm going to subtract x from both sides. Okay, actually I'm going to get rid of those underlines. I didn't mean to put them in there. I'm going to subtract x from both sides. And I'm going to do 2 steps at once. I'm also going to add 5 to both sides. And I know if I'm going to have the x's on the left-hand side that I want to get rid of the constant from the left-hand side, so it's only the right-hand side. So those cancel, that's why I did it. Those cancel, that's why I did it. And I'm left with 3x equals 17 plus 5 is 22. Divide both sides by 3. And I will get x is 22 over 3, or 7 1/3. So I'll leave it back for a second so you look at it. I suppose you can pause. All right, now this last one. In the previous question, I simplified some stuff first. And the same holds true here. I can simplify, I can expand this if I want to get rid of the brackets, which I sometimes have to do, but this time, this 3 divides both sides. So if I divide both sides by 3, that cancels off. I will have a plus 9 equals 15. And then I will subtract 9 from both sides, and wind up with A equals 6. Again, if I put 6 in there, 6 plus 9 is 15, times this 3 is 45, and look what we have over there, it's 45. That's not what I would call a formal proof, but at least you know you did it right.